for inviting me. That's a pity I can't actually be in Warsaw, but this does make it easier to give this talk. So I'm Marco. I'm a principal engineer at Microsoft, and I started working on Citus about 6 years ago, more than 6 years ago, when it was just like a tiny little startup in Turkey called Citus Data. And so nowadays we're part of Microsoft. We're offering Citus as a managed service on Azure. So today I want to kind of talk a bit about what is Citus, how does it work, and what can it do for you. And then I'll, if there's enough time, I'll kind of try to give a quick demo of a Citus cluster. So Citus is an extension to Postgres, an open source extension, and it turns it into a distributed database. And so most of what we do, you can see on our GitHub repo, citusdata/citus. It's usually a bit messy in terms of issues and pull requests, but pretty much everything that's going on is happening there. And then you can just install Citus on your laptop if you have Postgres already installed, or set it up on a VM. But maybe the easier way is to create a cluster on Azure. So if you go to Azure Database for PostgreSQL, there will be a option called Hyperscale Citus when you deploy a server, and then you can create a Citus cluster. So I often think of Citus as providing several superpowers, distributed database superpowers to PostgreSQL. And one of the superpowers it provides is this ability to create distributed tables where the data is actually distributed across many Postgres servers, which means that you basically have no more limits on the hardware, the amount of memory, the storage. So you can have tables of any size, like there's Citus users with tables of up to a petabyte, and then that putting your data in distributed tables gives all these other superpowers. The other thing we can do is the other feature that Citus adds is reference tables, which are basically almost the complete opposite of distributed tables. They need to be quite small because they are going to be replicated to every server in your Citus cluster. And the writes are going to be quite slow because the writes need to go to all the servers. So that sounds bad, but the big advantage is that they can be joined with the distributed table on any column. You can have foreign keys from the distributed table to the reference tables. And that means you can use much more compact representations in your distributed tables compared to what you see in a lot of other distributed databases. You often see that you have to put, maybe you have a NoSQL database, you store reviews, and in every review you put all the details of the user because that's the only way you can later find reviews by user or by a particular property of the user. In Citus, you would just create a reference table and have an ID in the distributed table that points to refers to the reference table and do a join. And that means that when you're dealing with a large amount of data in Citus, you can represent it in a much more compact way because of reference tables than you could in other distributed databases. Another kind of superpower is the ability to route queries to the right node. So if Citus knows, hey, actually all the data for this query is going to be on this one particular server, I'm just going to send this whole query to that server. And that server is always going to be a Postgres server, so it will know what to do with that query. And that allows it to just like really fan out all the queries across many servers and reach very high query throughput. Another superpower is copy. Copy is a lot faster on Citus than it is on a regular Postgres server, even on the same hardware, because Citus can parallelize the copy command. Also, any kind of query, select, insert, update, delete, DDL commands, create index, everything on Citus gets parallelized across all the cores on all the servers in the cluster. We can also scale out stored procedure calls. And finally, it supports distributed transactions. So if there's a transaction that affects multiple servers in the cluster, it actually all either commits or aborts as one unit. So when would you use Citus? Well, first, if you expect your database to be bigger than 100 gigabytes or it already is. And then, I mean, it doesn't mean that if your database is bigger than 100 gigabytes, you should use Citus, because a lot of databases are big, but then it's mostly kind of archival. We don't really, you might have 2 terabytes in your database that you never ever read, or that you only do kind of point lookups in. But if you actually very actively use a lot of that data, then a single server might not be able to keep up. But also, there are quite a lot of use cases, especially different types of alt-p use cases, where I mean, what we see a lot, for example, is like, you know, the application getting busier and busier, and the database is the bottleneck, but the problem in the database is lock contention. And basically, if lock contention is your bottleneck, the only thing that will make things go faster is to have lower latency. Now, if there's one thing that's not, you know, distributed databases are not good for, is for low latencies, because we'll have these network round trips. So not every workload will work well in a distributed database, but there are a few that work really well. One of them is multi-tenant workloads. So software as a service systems, where maybe you have your service has a whole bunch of users. They're relatively independent. You could have pretty complex transactions and maybe analytical queries within each particular user. But then, like, we can divide the data across the cluster by user, and so all those queries end up going to a single server. And that scales really well. Another thing that scales really well is real-time analytics. So if we have a large stream of data coming in from devices, like nowadays people talk a lot about Internet of Things, but basically we have sensors, or devices, they produce data, and we want to provide some real-time insights on that, maybe via a dashboard, or some system does alarming. For those cases, especially at scale, Citus can work very well. There's also other use cases. You can use it as a kind of document store, like you would use MongoDB or other NoSQL databases, and you have some benefits like parallel queries. It's not necessarily much better or much worse at these use cases, but it doesn't have such distinctive benefits in those use cases as it does in multi-tenant and real-time analytics. Similarly, data warehouse. So this is kind of the domain of Redshift and Greenplum. So Citus currently doesn't have something like columnar storage or the optimizations associated with it, but it can work well in data warehousing use cases where you can kind of optimize your data model and your indexes for a particular query set, if you already know like which queries you're going to run. But if the queries are kind of just very ad hoc, some analyst writes them, then Citus is probably not the best choice. So a Citus cluster usually looks something like this. There's a coordinator node, which is a Postgres server with the Citus extension, and then there are 0 or more worker nodes, which are also Postgres servers with the Citus extension. And the application typically just connects to the coordinator node. So that way, everything looks as if it is a single Postgres server to the application, because it just connects to a single Postgres server. But this is not written in stone. You can actually have multiple coordinators. You can have the workers act as coordinators, and the coordinator act as workers. So there's some flexibility around the setup. But in most cases, we see that a single coordinator is actually enough for most applications, because a coordinator can handle something like 100 to 200,000 transactions per second. And well, there's some extreme cases you can set up multiple coordinators. So the most important function that Citus adds as an extension to Postgres is create distributed table, where you specify the name of the table that you want to distribute and the distribution column. And what that does is my slide freezes a bit. So when you call that function, the coordinator will connect to the worker nodes and then create what we call shards, which are actually just regular tables on the regular Postgres tables. And each shard will contain a subset of the data, and the data is partitioned based on the distribution column. So my slides are a bit slow, sorry. So The data is using hash partitioning. So for every value that comes into the database, we calculate the hash, and that determines which shard the data goes into. Now, the distributed tables do have some limitations. So if you have a unique constraint on your table, then that unique constraint must include the distribution column. And the reason is that the worker, for other columns, the workers are not able to determine whether a value is unique across the entire cluster. Like within a particular company ID, the user can, or distribution column value, the user can say, okay, well, this value is unique for this particular company ID, but it cannot say like this value is unique globally. So that's a limitation. And then there's some limitations around foreign keys and joins, but we'll talk more about that later. And then there's some features which we haven't gotten around to implementing proper support for, but in most of those you can actually use them. And we have users that do. And the reason is that, for example, we don't propagate triggers at the moment. So if you create a trigger, it'll just throw an error. But the workers are just Postgres servers with regular Postgres tables. So you can go to a worker and create a trigger on the shard. And so that's what users do. So for some of these features where Citus doesn't have explicit support yet, but probably will in sometime in the near future, you could probably kind of hack around those by just connecting to the worker nodes. And so once you call create distributed table, every query, every command that involves this table will go through the Citus planner instead of the Postgres planner. So Postgres has this very nice pluggability that you can actually, an extension can replace the entire query planner with something else. And in this case, we just look at the query, say, if it does it have a distributed table? Yes, then we'll handle it. No, we'll give it back to Postgres. So what, for example, happens with an insert, Citus will look at what the value in the distribution column is. In this case, the distribution column is company ID, the value is Microsoft. From that, it determines which shard this insert should go into. It connects to the worker node that has that shard and then inserts into that shard. So then the insert will look almost the same, but the table name will be rewritten to the shard name. And then the way it picks the shard is it will compute the hash of the distribution column value, out comes some integer, and this just uses all the built-in hashing functions that Postgres already has. And then each shard corresponds to a different range of integers. So the shards cover the full range of all possible integers. And then we look at, okay, well, this hash value falls in the hash range of campaigns 102. So then we know we need to insert there. Similarly, if we get a select from campaigns where company ID equals Microsoft, we'll go through the same thing. We'll take the hash, find that, oh, this actually only needs to go to shard 102. So we'll just send the select over there if there is such a filter. Now, when it comes to inserts, Citus can do inserts at a pretty high rate, but it doesn't do anything particularly special for inserts. And it has a bit of an issue that because of the extra network round trip between the coordinator and the worker, you should expect the latency to be a little higher than for a regular Postgres server. And that means that also that the throughput on a single connection where you do insert, 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 insert is going to be a little lower because the inserts are going to take a little longer. You can kind of make up for that by making many connections. So if you do kind of a lot of inserts on Citus, you should have a lot of connections. But the other thing you can do is to use the copy command. So the copy command is followed by a stream of CSV formatted data. And what Citus does in this case is, okay, it gets a row, looks at the value in the distribution column, decides which shard it goes to, connects to the worker nodes, opens a copy command, sends the row, and then without waiting for it to be written, without waiting for the indexes to get updated, it'll read the next row and send that to the worker node. So you kind of it's kind of like acting like a card dealer at a poker table, kind of throwing all these rows to the different worker nodes, and they're all going to be ingesting those rows, updating the indexes in parallel. And so that's why even on similar hardware, Citus can actually give much better copy performance than Postgres. And then, of course, if you add more hardware, you add more worker nodes, you can get much higher performance. So that's one of the benefits of Citus, especially when you're dealing with like IoT data, events, time series data at a large scale that you can keep up with larger data volumes. And the difference becomes more pronounced. I mean, in this example, there's just one primary key index, but especially if you have many indexes on your data table, then writes will get slower and slower. But on Citus, because of the parallelism, you can still keep very high performance. And so that's one of the Citus superpowers. And then if you do, so we loaded some data with copy. Now, if you do a query on that data and there's no, like if there's a filter on the distribution column, we'll just send it to the worker that we know has the data for that particular distribution column value. If there's no such filter, we'll have to read from all the shards. But Citus can do that in parallel. So it'll open multiple connections per worker node and then start querying all the shards on that worker node at the same time. And it does that across all the worker nodes. And so it gets back all these results at the same time, and then usually has to do some merge step on the workers. It might have to like sum the sums that it gets back. This also depends a bit on, if you have a query with a group by, if you're grouping by the distribution column, we don't actually need to do any merge step on the coordinator. We can just give back the result because all the data for the company ID is on that worker. If you group by some different columns, then there might have to be some extra, you might get back more data, and then the coordinator will have to merge that. So how you distribute your data can affect your query performance in that way. So now we have like already some useful combination of capabilities. So you can write to Citus pretty fast, and you can also query the data pretty quickly by doing these parallel selects on it. And so here's an example of doing some analytical query on about 100 gigabytes of data, where on Postgres, and I'll actually try to show you this in the demo as well, might take like 5 minutes, where Citus will maybe take 10, 20 seconds to do the same thing, like a scan of the full 100 gigabyte, because it's spread across multiple machines. It can use multiple cores at the same time, but it can also, every machine has its own disk, so we have a lot more I/O capacity. We also have a lot more memory if we're dealing with a bigger cluster. So that way you can significantly speed up such select queries. And this actually also works for update, for delete, and also for inserts that select from another distributed table. Now, in addition to update and select, or addition to select and copy, another thing you can do in Citus is just regular transactions, like maybe begin, update, insert, select, delete, commit. So this is like a transaction block. And well, basically Citus supports arbitrary transactions. So if you can have transactions that span across nodes, you can have an update that's parallelized across all the shards and some other things, and then commit, and it's just all going to commit as one unit. But the ideal case is when your transactions kind of hit one worker node, because then you can handle many of such transactions concurrently, because you're only using like a single process on a single worker for that transactions, whereas you cannot handle so many super parallel updates across the entire cluster concurrently. And so we'll also have some performance numbers for that. So this uses a benchmarking tool, a database benchmarking tool called HammerDB to measure TPCC performance. And here you see actually on the same hardware, probably Citus will do a bit worse for these kind of transactions that only affect a small number of rows, because there's no gain. We cannot gain anything from parallelism. So Citus pretty much has to do the same stuff that Postgres has to do, but it might have a bit more overhead. There might be some latency. So typically, if you look at exactly the same hardware, you might see slightly worse performance from Citus. But if we're looking at 64 cores here, that's often like more or less the maximum that cloud providers offer you. So if you need more throughput than that, you're stuck. And then with Citus, you can actually just keep scaling out. So we can get more than 2 times higher throughput if you add more workers. Of course, cost more, but that might be actually worth it for your business. So kind of those are kind of the basic things you can do with a distributed table. You can scale out transaction throughput, copy, select, also the DML commands. But there are a few more advanced kind of data modeling features that we have in Citus that are also quite important. One is that distributed tables can be co-located with each other. So that means that, for example, I have a companies table, which has a company ID column, which is probably just the primary key. And then a campaigns table, which has a company ID column, which says this campaign belongs to this company. Now, I could distribute both of these tables on the company ID column, and then the same company ID value across these 2 tables will always be on the same worker node. So basically, the shards kind of get glued together between the 2 tables. And that enables some features and also some performance improvements. One is that you can now create foreign keys as long as they include the distribution column. And then that is implemented by just creating those foreign keys between the pairs of glued together shards. You can also join those 2 tables very efficiently if the join includes the distribution column, which in this case, because the company ID of the campaign kind of refers to the company table, it probably always does. And also, if you have an arbitrarily complex query, but it has filters on the company ID for both of these tables, we know, okay, actually this is on this one worker, so we can just send the entire query there. The other, and I'll give you some more examples of that. The other concept, which I alluded to earlier, is reference tables. So reference tables do not have a distribution column. They are fully replicated to all the worker nodes. That means you also don't have these limitations, so you can have unique constraints on any column. Also, you can create foreign keys from your distributed table on any column, or you can join them on any column. You can also join the reference tables together on any column. So this is really useful for your dimension table, where if you kind of have a star schema or a snowflake schema, you kind of can think of your distributed tables as your facts tables and your reference tables as your dimension tables, which are usually smaller and not changing that frequently. Because the main downside is they have lower write performance. Though some users do use them for extremely high read performance, because you can actually configure Citus to send a query on a reference table to a different node every time, and then suddenly you have like a cluster of nodes that can handle the same query. And so if you put those together, you could have a cluster that looks something like this, where items and users are distributed tables, both of them distributed by the user ID. You can have a foreign key from items to users on the user ID. Categories is a reference table, so you have the same copy of the data on all the worker nodes. You can have foreign keys to the categories tables, and you can join them all together as long as the both sides of the join include the user ID column. Then that join will just be completely delegated to the worker nodes. We'll just join each pair of shards. And that's not to say that if you don't do that, the join is not going to work. It's just to say that if you don't do that, the join is going to be a lot slower, because then Citus has to kind of pull a lot of data over the network. So it's better to kind of look at what queries do I want to do, and then make some kind of try to optimize your data model for those queries. So another important concept is router queries. So if you have these co-located tables like items and, well, here it's events, and let's say they're both distributed by user ID and and co-located, then this relatively complex query with subqueries and you can have other things in here like window functions, lateral joins, whatnot. But Citus can tell, oh, actually, there's a filter on the user ID on this items table. And also, we're joining this events table with the items table on the user ID. So this filter implicitly also applies to the events table. So I know that there's one particular worker that has all the data I need for this query. So it will take this entire query and just send it to that particular worker node. And that process has very little overhead. So I can take relatively complex queries and essentially use the coordinator as a very clever router that knows where to send the data just from looking at the filters in the query. Now, this is where what becomes very where Citus becomes very useful for multi-tenant applications, where like software as a service, like usually the tenants are relatively independent of each other. Even for things like email, if I go to Outlook or Gmail, I see my email and you see your email, but we're kind of relatively separate in that way. And so what you can then do if you have such an application is you can distribute everything by tenant ID or whatever it's called, customer ID, user ID. For that, you need to make sure that all your large tables do have a tenant ID column, which if you already have an existing application built on Postgres that's starting to kind of get a little too big for a single server, it can involve some work to make these schema changes, but you can usually do them on your existing Postgres server before you even consider migrating to Citus. And then you can on Citus distribute and collocate all your large tables using the tenant ID, such that you can join them together. You can have foreign keys between them. And for everything that's kind of across tenants, you can use reference tables or even just regular tables on the coordinator. And then the queries in your app that your application issues should have a filter on the tenant ID, such that Citus knows, okay, actually, I know this query belongs to this particular tenant. I can just send it to the worker. And because it can then do that with very low overhead, this model scales very well. So you basically, the advantage is you have no more limits on CPU, memory, storage, I/O capacity, and basically the amount of traffic you can handle is simply proportional to the amount of hardware you put in. And then, I mean, a traditional way of doing this, which actually a lot of big companies have applied, like Google, Facebook, Instagram, Skype, they all used to have manually sharded MySQL or PostgreSQL clusters for for many years before they started building something more custom. But this is a lot easier to manage because now you just have one schema for all your customers essentially. So if you want to add a column to somewhere, you don't have 1,000 databases for 1,000 different customers that you all need to go and modify. You can do analytics across your tenants. Everything still actually works on a single server, right? Like we don't do any kind of non-Postgres things in our queries. And also, if you compare it to another alternative, which is to migrate to a NoSQL database, especially if you already built your application on Postgres, this is a relatively straightforward migration. And with another type of database, you'd really have to rethink everything, essentially built from scratch. Now, it is still, very often we see that the need for scale goes hand in hand with complexity, like applications that have been growing for a few years, built a lot of features. So the process of adding these columns and these filters can actually take a few weeks or months, we usually see. But it's probably more attractive than most of the other alternatives that you have. And often for companies, it's also, okay, maybe they could spend a bit more time optimizing their schema, but that's not how the company necessarily makes money, right? They could spend their time doing something else that makes them more money, and then it's easier if you can just have the option of adding a server to handle more capacity if you have new customers coming in or your existing customers start using more of the database. So there's actually many different types of users that are kind of multi-tenant SaaS applications that run on Citus. There's CRMs, there's banks. I believe this is Bank of Australia. Yeah, so it doesn't really matter what type of application as long as there's some notion of relatively independent tenants. But sometimes you can also model your data to be relatively independent. I mean, I talked about email. Obviously, email, there's some relationship between the different tenants, but you could insert the email twice, for example, and you're already making things a bit more independent. So that's one good way, one use case in which Citus is very effective. The other use case is real-time analytics, where you have some number of data sources producing really large volumes of data, like mobile phones sending some statistics, or like sensors, windmills, like you name it. And as I said, ideally you can bulk load that data through copy, because that works really well in Citus, where inserts might actually work a bit worse than in Postgres. And then so you get this table of raw, maybe mostly unprocessed data. Now your dashboard could then query that data by using parallel select commands. And that can be pretty fast. But the other thing you can do, given that we've parallelized all these SQL commands, is do some transformations inside your database. So a common pattern is to create what we call a roll-up table. This is kind of like, and there's many different names. Could call like a summary table or an incremental materialized view. But basically, you pre-compute some of the some aggregates and store it in that table. And you typically do that using insert select. So you insert into the rollup table and select from the raw data, and then you typically try to do it such that you only select the new events and aggregate those. And then you can use things like onConflict do update to merge that into the existing records in the rollup table. And the rollup table is going to be a lot more compact than the raw data table. So if you have a really busy dashboard with many users, because maybe this is actually your product, you're offering an analytics product to customers, then this can be a very nice pattern where dashboard queries can answer in hundreds of milliseconds or even less, such that your dashboard actually remains relatively fast. And I mean, insert select is such an important command that we have several different implementations of it in Citus. So if you have an insert select, sometimes it can be done in a collocated way. So in this example here in the bottom, I'm selecting from the clicks table, and I'm selecting the site ID and the ad ID and inserting into the clicks by hour table. Now, if both of these tables are distributed by site ID, I can actually do this insert select, and they're collocated. I can do this insert select by just inserting into one chart and selecting from the collocated chart. Now, if that's not the case, then I may have to shuffle some data over the network. So that's the second implementation. The workers kind of pool the data from each other. And then sometimes the select has some extra merge step. So like it takes the top 10 items from one table and inserts that into the other table. And then we pull the data into the coordinator, but then copy it into the destination table. And because both of those steps, the select and the copy, are also quite fast, each of these implementations can actually perform really well. But it kind of comes down to being like the collocated one is probably able to do around 100 million rows per second. Repartitioning is around 10 million rows, and merge is around 1 million rows per second. Very roughly, depending on row sizes and those kind of amount of hardware. So I'll just go through one or two more slides, and then there's a question in the chat. I'll get to that. So the benefits of Citus for these real-time analytics use cases is that you can build this pipeline where basically every part of it is fast. So you can bulk load very quickly. You can transform the data inside the database very quickly. And then you can handle a very large number of queries from, let's say, a dashboard with very low latency. And so again, you have no limits on amount of CPU, memory, storage, and I/O capacity you have in this cluster. And then actually PostgreSQL is particularly good at dealing with large data. It has a lot of features, some of which are quite hard to use, but can be very effective. that help you deal with large amounts of data, such as partial indexes. And there's these extensions like HLL, hyperlog log, which help you do approximations of certain very heavy computations like the count distinct. And so if you combine all those things, then Citus is probably one of the best systems for this particular use case. And that's also why one of the biggest users of Citus, at least in terms of the size of the cluster, is actually the Windows team at Microsoft. So one example of a device is a Windows computer. And Windows devices send quite a bit of telemetry to Microsoft. Like those are things like you click the start button, and then Windows measures like how long it takes to render the start button, and that it sends that to Microsoft in a kind of anonymous way. And the purpose of that is that if Microsoft rolls out a new Windows version, they can see immediately on this dashboard, which has lots of different insights and charts, that latencies or things have gotten slower after rolling out those versions, or there's more errors after rolling out this version. And so there's an enormous amount of data coming in from these computers, well over a petabyte. But also this dashboard has quite a lot of engineering teams looking at it, so there's millions of queries per day. But most of those queries are answered in a few hundred milliseconds. All right, so I'll look at there was a question on, is Citus resilient to network partitioning and lags during the replication? So the way kind of fault tolerance and replication in Citus is usually handled is through, well, the same way as it's done in Postgres. So you would have, for example, in the managed service, if you enable H8, then every server in the Citus cluster gets a hot standby, and we use streaming replication to replicate to that hot standby. And so the way we implement the auto failover is actually resilient to network partitioning and replication lags. But it comes down more to being specific to how you implement the Postgres replication. So we have an extension, another Postgres extension called PG Auto Failover, which allows you to set that up on your own machine. But yeah, so basically it's the question applies primarily to the way you do streaming replication in your Citus cluster. Yeah, so going back to one of the first slides, so when to use Citus for large data sets. And it's especially powerful for these multi-tenant applications because of this ability to just route queries and transactions to the right worker nodes. So you can really scale out your capacity by just adding more servers. And it's not like that, you add more servers, but then the queries just also always go to all the servers, then that wouldn't scale as well in that use case. And there's a few migration steps involved if you already have a Postgres application. So if you're building a new application and you expect it to need to scale, it's handy to keep those things in mind. Maybe we shouldn't have a fully normalized data model. Maybe it's handy if every table already has our tenant ID column. But we also have some tools to help users who already have like a big complex Postgres schema to migrate those. And then for real-time analytics dashboards, Citus can use these various different levels of parallelism during bulk loading, during insert select, during queries to speed things up, even if you're dealing with a petabyte of data. I didn't really show these other two use cases, but we also have a lot of customers that fall into those. I think it's like, well, Citus can be very helpful. There's also alternatives there which may or may not be better, and I think that mostly comes down to like, do you like Postgres? And Citus is a kind of just an extension of Postgres, so all the other Postgres features and tools just work. And also, like, we keep Citus up to date with the latest Postgres. I think just today we merged all the changes into Citus to make it compatible with Postgres 13. So if you're trying out the Postgres 13 beta, you can actually use Citus extension with that. starting today. So I'll switch to a demo. Before that, are there any questions?
There's been one question. Oh, sorry, there's been a question about IoT and comparing to timescale DB. I think it was like pretty much answered already, but maybe you would like to add some comment here.
Yeah, I think, I mean, I did a good job of answering that. So, so timescale DB is primarily about partitioning, which is a very useful thing to do, partitioning the data locally, which is a very useful thing to do for time series data that, I mean, one important characteristic of time series data is that it usually doesn't change anymore once you've inserted it or once you've copied it into the table. And partitioning is then helpful for ensuring that, for example, like the partition you're inserting into is relatively small, so the indexes will be relatively small, so the inserts will be relatively fast compared to inserting into one giant table. And then there's other things like if you query by a particular date range, it becomes relatively efficient to just query by those particular partitions. Now, Postgres has built-in partitioning for that type of use case, but it's very bare bones. You have to kind of manually create every partition. There is an extension called pgpartman, which just makes that all very automatic. It sets up the partitions for you. And Timescale does that as well, and then also adds a number of useful features to deal with time series data. I think that Timescale now also has a distributed option. Just speaking from experience, it takes about 5 to 10 years to build a good distributed database. So I wouldn't expect that to scale as well as Citus just yet. So especially for these larger time series use cases, I would recommend Citus. For smaller ones, I think it can be a very nice option. So as Ian mentioned, it's available on Azure Database for Postgres as well. So there's one question is how Citus relates to partitioning. So if we think of the partitioning as the Postgres feature, actually quite a common model is for users to both partition their table partition is divided on disk into separate chunks per day or per hour, and then also distributed across worker nodes, for example, by a user ID or a customer ID. Such that you get both these benefits of partitioning, like smaller indexes, dropping all data quickly, faster queries on a date range, plus you get parallelism and the advantages of Citus. In the example that Gozdal is giving, where you already partitioned the data by user ID on Postgres, I guess, well, it would be possible to have like distribution and partitioning could even be done on the same column, but the benefit of that would be less clear. So I think if you're partitioning on user ID, you would probably just use that as the distribution column in Citus. Though it doesn't prevent you from also using partitioning. And then Fabrizio asked what, so as far as I understood, the coordinator can become a bottleneck, and are there ways to deal with that? Well, the thing is, yes, it definitely can. We just almost never see it actually happening because the overhead of routing and parallelizing these queries is actually very, very low compared to actually doing the work. So the number of transactions per second that a coordinator can handle is really quite high. And then there's things like copy, where you can just handle millions of rows per second, which is also quite high. The case where we most often see people run out of steam on their coordinator is in case of queries that return a relatively large amount of data from the worker nodes to the coordinator or even to the client. And that in that case, it is possible to set up another coordinator. Some users also just make every worker a coordinator, because the only thing the coordinator really needs to be a coordinator is a bunch of metadata. So it knows about the table schema, and it knows about, hey, this part of the data is on this worker node. So that is data that we can just copy to a different machine, and then it also acts as a coordinator. One limitation we still have, which is maybe why here the third line is not bold, is that if you set up many coordinators, then they will all be making connections, Postgres connections to the workers. And so at some point, you kind of run out of the number of connections that you can make to the workers reaches its limits. So the way to deal with that is to set up kind of internal PG bouncers, which create smaller pools of connections and then share it across different backends in the coordinator. But that's currently kind of a manual thing you have to set up, and so that's a bit tricky to do. I think in the future we'll make that a bit more seamless in the managed service as well. But I think when we implement that, I think then Citus is really competitive in this key value store space as well.
On that, using multiple coordinator nodes, that's not a feature in PaaS.
No, yeah, just to be clear, that's not.
You can set that up in your own if you're using the open source version of Citus. That's right.
Yeah, we do not have that in Hyperscale. So in Hyperscale, we just have the simple setup for one coordinator and 2 or more workers, which and as I said, like one coordinator is good enough in, and actually, like I would say 99% of cases. We've rarely, we deal with very large scale use cases, but it's very rare that actually the coordinator becomes a problem.
And you can also scale the coordinator node separately from all the worker nodes as well. So if you do hit a bottleneck, you can just go into the Azure portal, scale up the coordinator.
Exactly. Yes. And a beefy coordinator will easily handle hundreds of thousands of queries per second. So there's more questions, but I'll switch to the demo to make sure we're not running out of time. So I'll need to reshare, I think. And I'm kind of hoping that my SSH connection is still there. It kind of looks like it does, like it is. Okay, so I set up a Citus cluster with a few tables, and I kind of took the GitHub archive data, and if I use this, I'll also see like the sizes and the distribution columns. So the GitHub events table is my kind of raw data table. So I'm copying into that table. And then these other tables I kind of derive from the GitHub events table using insert select. So if I look at how many rows do I have in here, it's about 55 million. And you can already see that this query took about 0.7 seconds. So that means I'm counting about 70 million rows per second, which is more than a Postgres server can usually do. In fact, I also set up a 64-core Postgres server where I also did the select count star, and there it took around 5 minutes and 17 seconds to do the select count star on the same data size. And so this cluster has about has 5 worker nodes, 16 cores each. So it has slightly more hardware, like 80 cores. But yeah, basically when I run this select count star query, it sends select count star queries for all the shards in parallel, and that's how it gets the speed up. So I have this raw data, and basically it contains a lot of information. It comes directly from the GitHub archive, and it has information about everything that happens on GitHub. Basically, every time someone pushes some code to GitHub, there's an event in this data. And I loaded the month of January basically by just copying straight into the GitHub events table and downloading from the GitHub archive and just decompressing the JSON data that is there. And so I could do some analytical queries on it. So this query gives me the number of commits for the last 7 days, or in this case, the last 7 days of January. across all of GitHub. So, well, we can see all the queries that Citus is sending, and this takes around 10 seconds to complete. And then I also ran this on the Postgres server. It took around 10 minutes to do the same query. So, well, 10 seconds is nice, but if I have a dashboard with a lot of users all doing this query or a similar type of query, maybe with some different filters, I'm quickly going to run out of steam there, and then this query could also get slower. So one thing I did was I created this this derived table like Github Commits. I'll extract data from the GitHub events and put it in a more structured forms, put some indexes on it. And I also have this table with the number of commits per day per repository. So if I really just care about this particular statistic, then I can just use this rollup query. And so to maintain those two tables, I have a procedure which does an insert into GitHub Commits, and it does some complicated looking select, which selects from the GitHub events, and it only selects the new events which happened since the last time this function ran. And then it also updates the number of commits per day in the daily GitHub Commits table. So what I'll do is I'll copy in some more data. So I have the month of January, January. So this is kind of just copying in the first hour of February. And you can see the sort of parallelization where I'm copying into all the shards at the same time. So it took about 4 seconds. And now I'll do the function that does my insert select. And I mean, there's really a lot of stuff flying over the screen right now, but basically it's selecting the new events, then reshuffling it because the GitHub Commits table has a different distribution column, and then doing an insert into the daily GitHub Commits table, which has the same distribution column. So it only took like 2.5 seconds. And now if I look at my my GitHub Commits table, then I do the same query basically. I group by day and then count the number of commits in that table. So again, it gets parallelized, and now it took only 600 milliseconds instead of 10 seconds. So that's already an improvement. And you can see this is like number of commits in the first hour of February. And then I can also do use the daily GitHub Commits table, which only has the number of commits per day per repository. And so there it only takes like 100 milliseconds. And I mean, one step further, maybe actually my website just shows the number of commits per day for a particular repository. This is actually something that the GitHub website shows. It's really slow always to load this page, so they should maybe consider another database. But let's say I do that. This daily GitHub Commits table is actually distributed by repo ID. So there's one specific repo ID value. I know Citus knows this goes to one shard, can go to one shard. And then this is just pretty much a network round trip with some extra processing. So I can answer this in 2 milliseconds. And I could easily handle like thousands, hundreds of thousands of these types of queries. So if I have a dashboard with really a lot of users, these rollups are very useful to keep my query times very, very low. And I still have some flexibility to slice and dice this rollup in different ways. And then because the copy is fast and then the insert select is parallelized and only looks at the new events, I can keep up with very, very, very large data volumes. So this cluster is probably a bit too big actually to deal with just 100 gigabytes of data. All right, so I'll switch back to chat to see if there are questions. And I guess I should. Well, I'll just keep sharing the demo screen because I only had one slide left, which said, actually, it has some useful links. Let me put the slides back up. Hope this is going to work. Because I have to go to the last slide.
There is one question about PostGIS.
Yes, so the question is, does Citus work with Postgres extensions like PostGIS? Yes, it does. So yeah, you can use geometry types. You can do the types of queries that you do with PostGIS, where based on proximity, you find points. I mean, there are certain use cases for. I can go to the last slide easily. There are certain use cases of PostGIS where maybe Citus is not necessarily the best answer. Like if you, especially if you do these kind of spatial joins, like between two large data sets, for example, where within two large distributed tables, you're trying to find, what are the closest points between them. So Citus doesn't have any kind of particular optimizations for making that extremely fast. But if you're doing more like a slightly simpler queries where you're looking for all the points in a particular shape or particular points in close to another points, like those kind of simpler queries, Citus can do that extremely well because it can parallelize those across all the shards. So it depends a bit on the use case. I mean, I've seen some PostGIS use cases which do a lot of pre-processing of the data, and then those pre-processing steps can be pretty complicated. So it may or may not be able to help you there, but for things like, I mean, I recently saw this housing website, and you can, draw on the map, draw a shape on the map, and you'll see all the houses that are for sale within that shape. That is something that would be an excellent Citus use case. Like it can just query all the data in parallel and to find those the data points using PostGIS functions. And then, yeah, I just wanted to pull this up partly because someone mentioned this earlier, but if you want to use Citus data, don't go to like the Azure docs. I mean, they look okay, but go to docs.citusdata.com. It has like very rigorous tutorials, details on pretty much every Citus feature. It has tutorials on how to set it up locally on a single server, how to set it up on multiple servers, how to build a real-time analytics dashboard, a multi-tenant. So like docs.citusdata.com is a very good resource, and also the GitHub. I mean, that's the actual source code, so that's a sort of more advanced resource, but that you can see what we're doing there and what's going to be in future Citus versions. And there's a question of, is there some repo with those presentation examples? Yeah, I guess you're referring to the GitHub example. I do have a repo for it, but it's in an extremely shameful state. So I mean, I'll just share it, but don't expect it to be like expect undocumented shell scripts basically, because I kind of wrote it once for a demo, and then it was like, well, I'm never going to use this again. And then turns out I every few months I find a new reason to use it. So I wish I had spent a bit more time on it, but I'll share the link. But yeah, it needs a bit more documentation. And then there was another question on how the coordinator communicates with the worker nodes. So basically, it just uses libpq, or the Postgres protocol. It's kind of convenient. So libpq is the library that actually most Postgres drivers use underneath, like even for Python or Ruby, like they usually use libpq underneath, but it's actually also just a part of Postgres. So Citus doesn't even need its own Postgres client driver. It just uses the one that's already in Postgres itself. And then, yeah, so obviously it has a fair amount of failure detection logic. And I think that the most general answer of like, what is the behavior in case of failure is it rolls back. So whenever some error happens on the coordinator or a worker throws an error, then the coordinator throws an error, and then Postgres has these kind of abort hooks where we can say, oh, actually the transaction is aborting, and what we'll do then is we'll send abort to all the worker nodes, or we'll close the connection in some cases. And so that rolls back the entire transaction. So because everything is always happening in a transaction on the workers that doesn't commit until the coordinator commits, we can always kind of go back after a failure. And there's some cases where we'll like retry a few times if the connection fails to establish. But so that's the main behavior. There's atomicity, and then often it's, the client can retry the transaction, and there's a guarantee that we didn't leave anything behind. All right, I think I covered the questions in the chat probably. Yeah, any other questions?
Please feel free to unmute yourself if you've got any questions.
So Mike asked about rebalancing of data by adding new worker nodes. So yeah, there is a function called rebalance table shard. So basically, if you add a new worker node, let's say in Hyperscale, it'll show up, but it will not immediately be used. And unless you create a new table that goes there, until you run a function called rebalance table shard, and that sets up pick some shards and then sets up logical replication to start copying the shards to that new worker node. So basically, because we up front we create a lot of shards, even per worker node, we have multiple shards. We can just take some of them and then move those to the new worker nodes. And because it uses logical replication, your cluster just remains online, so writes still work while you're rebalancing. And then, yeah, I think one improvement we're making is right now, I think if you have very large reference tables, the writes to the reference tables block while we're adding a new node, which is usually not a problem because the reference tables are small anyway. But some users do end up with hundreds of gigabytes of reference tables, and so we're making that a sort of non-blocking operation using logical replication as well. So the next question is, how does Citus handle backups? That's a good question, and the answer is similar to the kind of question around availability and network partition handling. It's that we mostly rely on Postgres because these are just individual Postgres servers that we use the similar methods that Postgres uses for backups. So we take disk snapshots and we archive the write-ahead log into Azure blob storage, and at least in Hyperscale, but you do something similar in other environments. And but the one thing is we need to make sure that the backup is kind of in a consistent state. So there's this function in Citus which you can use to periodically put a marker into the write-ahead log of all the Postgres servers which is like a consistent state. If you recover all the server to that marker, you'll get a snapshot basically where you don't have one worker being slightly ahead of the other workers. And so then the way to recover the cluster is just to recover a whole bunch of servers at the same time, which is also a slight benefit that you can actually kind of do this parallel recovery to some extent. And yeah, so recovery of a corrupted worker, again, the answer is going to be similar to whatever it is for Postgres. So normal crash recovery, it'll just restart and then reapply the write-ahead log. Or if the server is down, we'd have a hot standby that takes over. There's a question of, is much downtime needed to migrate from a single PostgreSQL node to Citus? The answer varies. So we have tooling to use kind of logical replication such that you can keep writing to your Postgres server up till the very last moment, and all the data is already in the Citus cluster, and the writes are also going to the Citus cluster, and then you flip over. But I mean, it's more work to kind of set that up and to make it work nicely. So some users prefer to just, or end up just doing a kind of PG dump, PG restore type migration because it's easier. But it is possible to do a zero downtime migration. And then there's a question is, what if I remove a worker node? Is it a transparent operation? So this is something that we cannot do in the managed service yet in Hyperscale, but the extension itself supports it. So, but basically to actually remove a worker node, you'd first need to make sure that it no longer has any data on it, because otherwise that data would leave the cluster. So we have a kind of flag that we've set, and hopefully in the managed service, this is going to be all kind of automagical. But basically, we'll mark the node as it shouldn't have shards, and then when you run the rebalancer that I described earlier, it'll move shards away from that node, and then it can be safely removed. And then the next question is, the rebalancing function is not working if you're using Citus with the Docker community version. That is correct. That is something that we expect to change very soon. So hopefully we'll have an update on that within the next few months. All right. You're welcome. Well, these are very good questions. Like, you're giving me, you're not making it easy for me, but yeah, if anyone else has questions, I still have some time, so I can hang around. Is it possible to configure Citus on Kubernetes? For sure, and but we don't have a lot of publicly available tooling at the moment. So which has been unfortunate, but I think one thing we'll have in the near future is Azure Arc. So that's basically a kind of a way to provide Azure services via Kubernetes, and Citus will be, like when that becomes available, Citus will be one of the databases that you'll be able to use on Azure Arc. And it's basically a kind of Kubernetes in a box. All right. Well, thanks everyone for attending. So you can also reach me on marco.slot@microsoft.com, and yeah, have fun trying out Citus, playing with Citus, and let us know what you think.
Thank you a lot, Marco.
Sure.
So I will upload the video on our YouTube channel for those who could not join us. So thank you a lot, and have a great, I'm not sure in which time zone you are, but
I'm in Amsterdam, so probably a similar time.
Yeah, so have a great evening, and thank you a lot for that.
Thank you. Everyone have a good evening too.
Yeah, bye. Bye all.